Okay guys, welcome back. So in the last video I explained to you about the introduction to partial fractions, and in the last video I explained to you about a simple problem in which we had the same power for the numerator as well as for the denominator, and we solved for the partial fractions and found the values of a and b which I took as the constants. So in this video I'll be talking about another approach to partial fractions where we have some powers inside the brackets. Now first of all you need to understand, now if you have something like this, if you have say in the last video we talked about the concept of in the introduction of partial fractions, the highest power of the numerator and the highest power of the denominator were equal, but if the highest power of the numerator is less than highest power of the denominator, then also we can write it similarly. But when we have something like this, say I'll take the same example for the numerator, but I'll change the denominator. So if we have something like this, say x squared plus 6x plus 8 divided by, now I will take x minus 3 as it is, but what I'll do here is that now I'll not take the next term to be x plus 4 as I did in the last video. I'll take it to be x squared plus 4. X squared plus 4, and now I'll find the partial fractions for this. Now first of all you need to understand that about the powers of these two of the numerator and the denominator. So the highest power of the numerator is 2 and the highest power of the denominator should be now 3, because we have x times x is x cubed and the other terms do not exceed that power. So the highest power of the denominator is 3 and the highest power of the numerator is 2. So 2 minus 3 is minus 1. So we have the we can write a function with power of minus 1, right? The highest power we can write is either a constant or linear expressions, quadratic expressions like that. So we can write a function, say x something to power x to power minus 1 plus something to power x to power 0, something like that. We can start only with a constant. So we can write algebraic function here. So now as I mentioned in the last video, what you have to do here is that you have to separate these functions into two separate fractions, right? Separate this function into two separate fractions. So what actually happens is that, as in the last video, I'll write the first fraction to be a divided by x minus 3 plus, now I have for the next fraction I have the denominator to be x squared plus 4. As I mentioned in the last video, if you have something like this, inside this bracket, if you have some squared or cubic term inside this bracket, what you have to do is you have to write an expression which has 1 less than the power of the numerator. Now as in the last video we had here x plus 4, so 1 less than the highest power of the denominator in this fraction is now 1, right? In the last fraction was 1, so 1 minus 1 is 0, so we have to write a constant. But in this case we have a power of 2 here. Here the highest power is 2, so we have to write the numerator in the form of a degree of x in which we have the power of 2 minus 1, which is 1. So we have to write a linear expression here. So I'll take the linear expression to be something like bx plus c. Similarly, if we have a cubic term here, the highest power of the denominator is 3, and we have to write a quadratic expression here, bx squared plus cx plus d or something like that. So these values need to be a, b and c. You can take p, q, r, o, any fraction, right? Any English terms here, right? So these need to be a, b, c always. You can take it to your wish, but you need to understand about the rules of dividing these into partial fractions. So in this case, what I will do is that as in the last video, I will multiply both sides by the denominator of the function or the fraction in the left side. So I have to multiply both sides by x minus 3 times x squared plus 4. So when I multiply the left side by x minus 3 times x squared plus 4, that term and this denominator will cancel off, and I am left with the numerator. So my numerator will be x squared plus 6x plus 8, right? x squared plus 6x plus 8. And when I multiply this one, when I multiply this term, a divided by x minus 3 by x minus 3 times x squared plus 4, x minus 3 and x minus this x minus 3 will cancel off, and I am left with x squared plus 4, and I have to multiply that with a. So I will get here a times x squared plus 4 plus, now I will take the denominator as it is inside this bracket, bx plus c, right, bx plus c times. Now when I multiply this term, this fraction, by x minus 3 times x squared plus 4, x squared plus 4 and this x squared plus 4 will cancel off, and I am left with x minus 3. So here I will get x minus 3. Now in order to solve this, I will go for another step, because I can further solve this inside according to the brackets, right? So according to the brackets I have got here. So I can say x squared plus 6x plus 8 is now equal to a times x squared plus 4, right, a times x squared plus 4 plus bx times x minus 3 plus c times x minus 3. So I'll take this to be now equation 1, this to be equation 1. Now you have to find the values of a, b and c here. So to find find the values of a, b and c, since this also called an identical function, I can equate the coefficients of both sides. So when I equate the coefficients, I can equate square terms. So when I equate x squared of both sides, x squares, in the left side I am left with 1. In the right side, when I multiply a with this x squared, I will be remaining with ax squared, and the coefficient of x squared there is a. And from this term, I can say bx plus x is bx squared. So the coefficient of x squared is now b plus b. And from this term, I am not left with any x squared coefficient or x squared term. So a plus b is 1. So that will be my second equation. And my third equation will be by equating x values of both sides, by equating the coefficients of x values of both sides. So in this side, in the left side, I am left with 6x. So the coefficient of x is 6. So I can write 6 equals. In the right side, a times x squared is ax squared, a times 4 is 4a. So I am not left with a coefficient of x from this term. From this term, so these are 3 terms, right? 3 terms. In this term, I am not left with any coefficient of x. When I go to this term, I am left with one coefficient of x, which is bx times minus 3, which is minus 3bx. So minus 3bx, so the coefficient of x is minus 3b. So I get here minus 3b. And in this term, I am left with c times x is cx, that is plus cx. So the coefficient of x is plus c. So I am left with minus plus c, right? So this will be my third equation. So I have 3 unknown terms, so I need 3 equations to solve. So my third equation will be by equating the constants. So I will take constant, right, by equating constants. So the constant in the left hand side is 8, plus 8. So 8 equals, I can write 8 equals, I can say this a times plus 4 is plus 4a. So the coefficient of actually the constant is plus 4a, right? 4a. And since we have x here inside b, we will not get a coefficient of a coefficient for the constant here, because when we multiply x by any term, we will not get a coefficient here. So in this term, when you multiply c by minus 3, you will get another coefficient which is minus 3c. Alright. So we have one equation with a and b, another equation with b and c, and another equation with a and c. So this is actually interesting. So first of all, what I will do is that I will eliminate for b. To eliminate for b, what I will do is that I will multiply this second equation by 3. So I have 3b here, and when I add up that 3b with this minus 3b, I can cancel b off, and I can have another equation with a and c. Then I will solve for a and c, and then finally substitute the value of b A and C, either A or C, to find the value of B. So I'll multiply second equation by 3. So I'm left with so 1 equals A plus B. So when I multiply this one by 3, I'll get 3 equals 3A plus 3B. This is my fifth equation. So what I'll do next is, since I have plus 3B here and minus 3B here, what I'll do is I'll add the third equation to the fifth equation. So this plus 3B and this minus 3B will cancel off. So in the left hand side I am left with 3 plus 6, which is 9. 9 equals, so these two cancel off, 3A, and here plus C. So that is 3A plus C. 3A plus C, equation number 6. Equation number 6. So that's my equation number 6. Alright. So my next equation will be, so I have 8 equals 4A minus 3C is the fourth equation, and 9 equals 3A plus C. 9 equals 3A plus C, which is the sixth equation. So I can easily find the value of A by multiplying this one by 3 and adding these two up. So that will be 27 equals 9A plus 3C, which is 7. So I have here 8 equals 4A minus 3C and 27 equals 9A plus 3C. So what I can do here is that I can add the equation number 4 with equation number 7, so that this 3C and this minus 3C will cancel off. So I am left with, the left hand side is 27 plus 8, which is 35. 35 equals, right, 35 equals, this 9A plus this 4A is 13A. So I can say A is equal to 35 by 13. A is equal to 35 by 30. So I can substitute the value of A here and find the value of C, right? So 9 equals, for this equation you can say 9 equals 3A plus C. So 9 equals 3A. So 3A is 3 times 35 by 3. So 3 times 35 is 105. So 105 by 13 plus C. So now C is equal to 9 minus 105 by 13. 9 minus 105 by 13. So when I take a common denominator, 9 times 13 is 117. So 117 minus 105 is 12. So I'll get here 12 by 13. Right, 12 by 13. So from the last equation, from the second equation, what I can say is that 1 is equal to now A plus B. 1 is equal to A plus B. So I can substitute the value of A here, and again I can find the value of B. So those are the constants I needed to find the partial fraction of this function. So from the second equation I can say, right, I can say A plus B is equal to 1. Plus B is equal to 1. So B is equal to 1 minus A, which is 1 minus here 35 by 13. A is 35 by 13. So 13 minus 35 is minus 22 by 13. Now as the last step of this finding the partial fractions, what I'll do is that now I'll substitute the values of A, B and C into this one, and I'll say that these two both sides are accurate, right? So the left hand side I am left with x squared plus 6x plus 8, x squared plus 6x plus 8 divided by x minus 3 times x squared plus 4 is equal to now a. So a we found to be 35 by 13, right? A we found to be 35 by 13. So that divided by 35 by 13 times x minus 3, right? Plus, since b is minus, what I'll do is I'll write bx plus c as c plus bx. So c is equal to we found to be 12 by 13, b is equal to minus 22 by 13. So I can write this one as 12 minus 22x over 13 times x squared plus 4, right? So if you are not sure about this, you can multiply, you can take a common denominator here and you can solve for this and find whether you get the right hand side solves for the left hand side. So that's just an exercise for you, but this should be accurate. I'm pretty sure about it. So that is the next example. That's the second example I took in this series of videos on partial fractions to elaborate about the way when we have some power inside a bracket in the denominator. And in the next video I'll be talking about the inclusion of linear expressions in the case of partial fractions. And thanks for watching this video, and see you then.